In this lecture we find out the length of line segment X. In the drawing we have a quarter circle. FAE is a quarter circle. Inside this quarter circle we have square ABCD, and we know that line segment DE, this line segment DE equals to 12 units in its length. This is angle GDC is equal to theta. This is angle CDE, it is also equal to theta. And our mission is to find out the length of this line segment GD that is equal to X. Okay. So first of all, we know that ABCD is a square, and therefore side DC is parallel to side AB. So write it down. Side DC is parallel to side AD. Again, in square ABCD, side DC is parallel to side AD, and therefore DC must be also parallel to AE. DC is also parallel to AE. Side DC must be also parallel to AE, because if we have a straight line that is parallel to part of the side, again, AB is part of AE, and we know that DC is parallel to AB, therefore DC must be also parallel to AE, because if a straight line is parallel to a part of the other straight line, then the straight line itself must be also parallel to the straight line itself. Therefore, DC must be also parallel to AE. And from the fact that DC is parallel to AE, we derive that those two angles are equal to each other. That is to say, we derive that this is angle EDC that is equal to theta, and it must be equal to this angle, that is actually angle AED. And again, angle EDC must be equal to angle AED, according to the rule that alternating angles between parallel lines are equal to each other. DC is parallel to AE, and those two angles are alternating angles that are located between the parallel lines DC and AE, therefore they must be equal to each other. But this is angle EDC that is equal to theta, so we can write there that angle ADC equals to theta, according to what is given in the equation, and from this equation, theta equals to angle ADC equals to angle AED. We derive that angle AED is also equal to theta. So this is angle AED, that is must be also equal to theta. We know also that all the angles inside square ABCD are right angles, so this angle is a right angle, this angle is also a right angle, this is also a right angle, and this is also a right angle. In the next step, we'll do a construction, that is to say, from point G, we'll do perpendicular on AE. Again, from point G, we draw perpendicular on AE. So this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point G and AE as N, and we define the intersection point of the perpendicular GN with DC as M. So inside quadrilateral DMAN we have 1, 2, 3 right angles, and therefore this fourth angle must be also equal to 90 degrees according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Likewise, inside this quadrilateral MC and D we have 1, 2, 3 right angles, therefore the fourth angle must be also equal to 90 degrees in its size according to the same rule that the sum of the angles in any quadrilateral is equal to 360 degrees. If we focus on the left side of perpendicular GN, this is absolutely a straight line. In the left side of the perpendicular GN at point M, the sum of the angles must be equal to 180 degrees. So which angles we have at the left side of the straight line GN at point M? We have this angle that is 90 degrees, plus the missing angle. In total they must be equal to 180 degrees. According to the rule, then the sum of the angles on one side of a straight line is equal to 180 degrees. Therefore, the missing angle must be equal to 90 degrees in its size. Okay. In the next step, we'll focus on the right triangle DGM. So I copy the right triangle DGM in a new page, and we'll analyze the right triangle DGM. The hypotenuse DG equals to x. X is the variable that we are looking for. Angle MDG equals to theta. Okay, this is the right triangle DMG that I copied from the original drawing. This triangle DMG, cosine theta equals to dm over dg. So cosine theta equals to dm over dg. dg is x, so substitute dg by x. So we multiply this equation by x, and we get that according to equation 1, dm equals to x times cosine theta. Okay, dm equals to x times cosine theta. In the next step, we'll focus on the right triangle ADE. So I will copy the right triangle ADE in a new page, and we'll analyze this right triangle ADE. the hypotenuse D equals to 12 units in its length according to what is given us the question. We will define the length of one side of this square ABCD as y, therefore AD will be equal to y. AB also will be equal to y. BC will be equal to y according to our definition, and finally DC must be also equal to y. Okay, this is the right triangle ADE that is according to the original drawing. This right triangle ADE cosine theta is equal to AE over DE. So cosine theta equals to AE. That is the missing side over DE, that is 12. Actually, AE is the radius of this quarter circle. We define the radius of the quarter circle as capital R, therefore AE equals to capital R. So cosine theta equals to AE, that is capital R according to our definition, over 12. So in conclusion, we found out that according to equation 2, cosine theta equals to R over 12. Cosine theta equals to R over 12 according to equation 2. While according to equation 1, we have already found out that dm equals to x times cosine theta. So actually we can substitute cosine theta in this equation 1, by r over 12 from equation 2. We'll do it now, and we get that according to equation 1, dm equals to x times cosine theta, and cosine theta according to equation 2 is r over 12. This is r over 12. So in conclusion, we actually found out that dm equals to x times r over 12. dm equals to x times r over 12. dm equals to x times r over 12, and so write it down, dm equals to x times r over 12, and we also know that quadrilateral DMAN has 4 right angles. Any quadrilateral that has 4 right angles must be at least a rectangle if not a square. So we will relate this quadrilateral DMAN before right angles as a rectangle. And we also know that the opposite sides of a rectangle are equal to each other. So in rectangle DMAN, side DM must be equal to the opposite side AN. But DM equals to x times r over 12, therefore AN must be also equal to x times r over 12. Okay. AN equals to x times r over 12. Likewise, according to the same rule, in the same rectangle ADMN, side AD must be equal to the opposite side MN. but AD equals to y according to our definition, therefore MN must be also equal to y. In the next step, we return to our right triangle DGM. So I copy again the right triangle DGM in a new page. So actually, this is the right triangle DGM that I copied from the original drawing. This right triangle DGM sinus theta equals to GM over DG. Again, sinus theta in the right triangle DGM equals to GM over dg. So sinus theta equals to gm, that is the missing side, so we leave it as it is, over dg. dg equals to x, therefore substitute dg by x. So in conclusion, I should found out that sinus theta equals to gm over x. Here we will multiply this equation 1 by x, and we get that according to equation 1, gm equals to x times sinus theta in the next step. We'll focus on the right triangle ADE, so I'll copy the right triangle ADE again. Side AE equals to r, it is the radius of the circle. And D equals to 12 units according to what is given as the question. So this is the right triangle AD that I copied from the original drawing. In this right triangle ADE, sinus theta equals to AD over DE. AD equals to y, according to our definition. So sinus theta equals to AD that is y over DE that is 12. So in conclusion, I shall find out that according to equation 2, sinus theta equals to y over 12. So we can substitute sinus theta in this equation 1 by y over 12 from equation 2. We'll do it now. And we get that according to equation 1, gm equals to x times sinus theta, but sinus theta is y over 12. So in conclusion, I should have found out that gm equals to x times y over 12. So I write it down in the original drawing that gm equals to x times y over 12. Here gm equals to x times y over 12. Okay, so in the next step we will join points A and G together by a straight line. By joining points A and G, we created the right angle triangle AGN. So I will copy the right angle AGN in a new page, and we will implement on this right angle AGN the Pythagoras theorem. The hypotenuse AG is the radius of the circle, is equal to capital R. We have already found out that AN equals to x times R over 12. Side GN equals to GM plus MN. That is to say, side GN in total equals to xy over 12 plus y. So actually, this is the right angle AGN that I copied from the original drawing. According to the Pythagoras theorem, in this right angle AGN, AG squared equals to AN squared plus GN squared. AG is R, therefore AG squared is R squared, and it is equal to AN squared. AN is R x times R over 12, therefore AN squared is x squared times R squared over 12 squared, that is 144, plus GN squared. GN is x y over 12 plus y, therefore GN squared is xy over 12 plus y squared. In the next step, we will take y as a common factor from this expression, and we get that r squared equals to x squared times r squared over 144 plus, so we take y as a common factor from this expression. So inside the brackets we will have here x over 12 plus, we took y as a common factor, so inside the brackets we left with 1 square. So we will open the brackets of this equation, and we get that r squared equals to x squared times r squared over 144 plus, here we have y squared times x over 12 plus 1 squared. So here we multiply 1 by 12 and then we divide it by 12 in order to account factor with x over 12, and we get that r squared equals to x squared times r squared over 144 plus y squared. We have here x plus 12. We multiply by 12 and then we divide it by 12 in order to account factor with x over 12. And we get that x plus 12 over 12 squared. So here we divide x plus 12 over 12 square equals to x plus 12 square over 12 square. So I write it down, and we get that r square equals to x square times r square over 144 plus y square. Here we have x plus 12 square over 12 square, this is 144. So, according we actually found out that according to equation 1, r square equals to x squared times r squared over 144 plus y squared times x squared plus 12 squared over 144. In the next step, we join points A and C together by a straight line. And we'll implement the Pythagoras theorem on the right triangle ABC. So I'll copy the right triangle ABC in a new page and we'll implement on it the Pythagoras theorem. Side BC equals to y, according to our definition. Side AB also equals to y. And the hypotenuse AC is equals to r because it starts from the center of the circle and ends at point C, that is the point of the circle itself. Therefore, it is equals to r. So, this is the right triangle ABC that I call it from the original drawing. According to the Pythagoras theorem, in the right triangle ABC, AC square equals to AB square plus BC square. AC equals to r, therefore AC square is r square. And it is equals to AB square. AB is y, therefore AB square is y square plus BC square. BC is also y, therefore BC square is y square. So we actually found out that r square equals to y square plus y square, that is 2y square. Okay. So according to equation 2, r square equals to 2y square. So we can substitute r square in this equation, equation 1, by 2y square from equation 2. We'll do it now, and we get that according to equation 1, r square, it is 2y square, and it is equals to x square over 144 times y times r squared. And r squared according to this equation 2, is 2y squared plus y squared times x plus 12 squared over 144. Here we will divide this equation by y squared, and we get that according to equation 1, here we have 2y squared over y squared is 2, and it is equals to, here we have y squared, so y squared will get cancelled, and we have to leave x squared times 2 over 144 plus, here y squared will get cancelled, x plus 12 squared over 144. So here we multiply this equation by 144, and we get that according to equation 1, 2 times 144 is 288, and it is equals to 2r squared plus x plus 12 squared. So we can find out that according to equation 1, 288 equals to 2x squared plus x plus 12 squared. Here we'll open the brackets on this side of the equation, and we get that according to equation 1, 288 equals to 2x squared plus x plus 12 squared equals to x squared plus 12 squared, that is 144, plus 2 times x times 12 is 24 x. So according to equation 1, 288 equals to 2x squared plus x squared is 3x squared plus 24x plus 144. Here we subtract 288 from this equation 1, and we get that according to equation 1, we have 3x squared plus 24x, and 144 minus 288 equals to minus 144, that is equals to 0. So we have here a quadratic equation. We divide this quadratic equation by 3, and finally we get that 3x squared over 3 is x squared, plus 24x over 3 is 8x, minus 144 over 3 is 48, minus 48. That is equal to 0. Again, this is a quadratic equation, and the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. In this general formula, a, b, and c are the coefficients of this quadratic equation, and x is the variable that we are looking for. We find out the value of x according to the following formula: x equals to minus b plus minus square root of b squared minus 4 times a times c over 2a. Okay. In our specific quadratic equation, that is to say x squared plus 8x plus 48 equals to 0, the coefficient a equals to 1, the coefficient b equals to 8, and finally the coefficient c equals to minus 48. So we put the value of a, b, and c for our specific quadratic, specific quadratic equation, in order to find out the values of x for our specific quadratic equation. I remind you that x is the variable that we are looking for. X is the left of line segment dg. So we do it now, and you get that x equals to minus b. b is 8, so minus b is minus 8, plus minus square root of b squared. b is 8, therefore b squared is 8 squared, that is 64. Minus 4 times a is 1, a is 1, so minus 4 times 1 is minus 4, and minus 4 times minus 48 is plus 192, divided by 2a. a is 1, so 2a is 2 times 1, that is 2. So if we actually found out that x equals to minus 8 plus minus, inside the root we have 64 plus 192 is 256 divided by 2. So if we actually found out that x equals to minus 8 plus minus, and the square root of 256 is 16 over 2. So here we have two solutions that are possible for x. The negative solution is irrelevant. Why? Because of the fact that x is a length, and the length must be a positive number. Therefore, the negative solution is the incorrect solution. So we'll focus on we'll take into account only the positive solution for x. And the positive solution for x is that x equals to minus 8 plus 16 over 2. Minus 8 plus 16 is 8, and 8 over 2 is 4. We already found out that x equals to 4 units in its length. I repeat again. I can find out that x, that is the length of this line 7DG, is equal to 4 units in its length. So in the next step, I will summarize the lecture. In this lecture, we found out the length of this line 7DG is equal to x. So in the drawing, we have a quarter circle. AFE is a quarter circle. Inside this quarter circle, we have square ABCD. We know that this is line 7DE, that's equal to 12 units in its length. This is angle GDC. This is equal to theta. This is angle EDC. This is also equal to theta. Again, our mission is to find out the length of this line 7DG. This is equal to x. Okay. So first of all, we know that all the angles inside the square are right angles. So those 4 angles are right angles. And we also know that the opposite sides of a square are parallel to each other. So in square ABCD, side DC is parallel to side AB. Okay, again in square ABCD, side DC is parallel to side AD. So DC is parallel to AD. We know that AE or AB is part of AE. Again, AB is part of AE. So if part of a straight line is parallel to another straight line, then the straight line itself must be also parallel to the other straight line. And therefore, DC must be also parallel to AE. Because part of AE is parallel to DC, therefore AE itself must be also parallel to DC. Okay, so DC must be also parallel to AE. And from the fact that DC is parallel to AE, we derive that those two alternating angles must be also equal to each other, according to the rule that alternating angles between parallel lines are equal to each other. DC and AE are two parallel lines, and those two angles are located in between those two parallel lines, and therefore they are equal to each other. Again, angle EDC equals to angle AED, according to the rule that alternating angles between parallel lines are equal to each other. But this is angle EDC is equal to theta, according to what is given as the equation. So we can write here that angle EDC equals to theta, and from this equation, theta equals to EDC equals to AED. We derive that angle AED also equal to theta. So this is actually angle AED that is also equal to theta. Okay, in the next step, we did the construction, that is to say, from point G, we draw perpendicular on AE. Again, from point G, we draw perpendicular on AE. So this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point G and AE as N. We define the intersection point of the perpendicular GN with DC as M. So here we have inside this quadrilateral DMAN, we have 1, 2, 3 right angles. Therefore, this fourth angle must be also equal to 90 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Likewise, if we focus on quadrilateral MCBN, we have inside this quadrilateral MCBN, we have 1, 2, 3 right angles, and therefore this fourth angle must be also equal to 90 degrees in size, according to the sum rule that the sum of the angles in any quadrilateral is equal to 360 degrees. If we focus on the left side of the straight line GN at point M, here the sum of the angles must be equal to 180 degrees, according to the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. Therefore, this missing angle, that is to say angle GMD, must be equal to 90 degrees in its size. And therefore, triangle DMG is a right angle. So copy the right angle DMG in a new page. And in this right angle DMG, it is very easy to see that cosine theta equals to dm over dg. Again, cosine theta equals to dm over dg. So cosine theta equals to dm over dg. dg is x, so cosine theta equals to dm over x. Here we multiply this equation by x, and finally we found out that dm equals to x times cosine theta. According to equation 1, we actually found out that dm equals to x times cosine theta. Then we focus on the right angle ADE. This right angle, triangle ADE. This is the right angle ADE. So I copy the right angle ADE in the new page, and then analyze this right angle, triangle ADE. This is the right triangle ADE that I copied from the original drawing. According to our definition, side AD equals to y. It is given as the equation that D equals to 12. And we already found out that this angle AED is equal to theta. So in this right angle ADE, it is very easy to see that cosine theta equals to AE over DE. Okay, cosine theta equals to AE over DE. AE, line segment AE starts from the center of the circle and ends at point E, that is the point of the circle itself. Therefore, AE is the radius of the circle, that is equal to R according to our definition. So AE equals to R and D equals to 12. So in conclusion, we actually found out that cosine theta equals to R over 12. So here, according to equation 2, we actually found out that cosine theta equals to R over 12. This is according to equation 2. But according to equation 1, we have already found out that dm equals to x times cosine theta. Again, dm equals to x times cosine theta. Now we can substitute cosine theta in this equation 1 by r over 12. We did it and we found out that dm equals to x and cosine theta is r over 12. Therefore dm in total equals to x times r over 12. Okay, here dm side dm equals to x times r over 12. But because of the fact that dm inside dm we have 4 right angles, we can relate to this quadrilateral dm with 4 right angles as a rectangle. And you also know that the opposite sides of a rectangle are equal to each other. So in rectangle dm side dm equals to side an. dm equals to an, but dm equals to x times r over 12, therefore an must be also equal to x times r over 12 because they are equal to each other. Likewise, in the same rectangle ADMN, side AD must be equal to the opposite side MN, but AD equals to y, therefore MN must be also equal to y. In the next step, we focus on the right triangle ADE. So I copy the right triangle ADE in the new page, and we actually focus on the right triangle DGM. The right triangle DGM, so I copy the right triangle DGM here, and in this right triangle DGM, sinus theta equals to GM over DG. Again, sinus theta equals to GM over DG. So sinus theta equals to GM over DG, and DG is x. So in total, we actually found out that sinus theta equals to GM over x. We multiply this equation by x, and finally found out that GM equals to x times sinus theta. According to equation 1, GM equals to x times sinus theta. Then we focus again on the right triangle ADE. So I copy the right triangle ADE here and analyze this right triangle ADE. So in the right triangle ADE, it is very easy to see that sinus theta equals to AD over DE. Again, sinus theta equals to AD over DE. And AD equals to y. You know that AD equals to y. Therefore, sinus theta equals to AD, this is y, over DE. DE is 12. So we found out that sinus theta equals to y over 12. According to equation 2, sinus theta equals to y over 12. So we can substitute sinus theta in this equation 1, by y over 12 for equation 2. We did it, and we actually found out that the GM equals to x, and sinus theta is y over 12. So in total, GM equals to x times y over 12. Repeat again. We actually found out that GM equals to x times y over 12. Then we focused on, we actually joined points A and G together by a straight line. By joining points A and G, we created the right triangle AGN. So I copied the right triangle AGN here. And AG, the hypotenuse AG is the radius of the circle that is R. GN equals to y plus x times y over GN equals to y plus x times y over 12, and AN equals to x times r over 12. Here we implemented in this right triangle AGN the Pythagoras theorem. According to the Pythagoras theorem in the right triangle AGN, AG square equals to AN square plus NG square. Again, AG square equals to AN square plus GN square. So AG is r, therefore AG square is r square, and it is equals to AN square. AN is x times r over 12, therefore AN square equals to x square times r square over 12 square, that is 144, plus GN square. GN equals to x times y over 12 plus y, therefore GN square equals to x times y over 12 plus y square. Here, we took y as a common factor of this expression, and we actually found out that r square equals to x times x squared times r squared over 144. Here we took y as a common factor from this expression, so inside the brackets we left here for this expression x over 12, and from this from y we left with y inside with 1 inside the brackets. So if we found out that r squared equals to x squared times r squared over 144 plus y times x over 12 plus 1 squared. Then we open the brackets here and we found out actually that r squared equals to x squared times r squared over 144 plus, here we open the bracket, so it will be y squared, and here we have x over 12 plus 1 squared. Here we multiplied 1 by 12 and then we divided by 12 in order to have a common factor with x over 12, and we actually found out that r squared equals to x squared times r squared over 144 plus y squared. Inside the brackets we have x plus 12 over 12 squared. So here we have x plus 12 over 12 squared, that is equals to x plus 12 squared over 12 squared. Okay, and finally we actually found out that according to equation 1, r squared equals to x squared times r squared over 144 plus y squared, and again x plus 12 over 12 squared equals to x plus 12 squared over 12 squared, that is 144. So in conclusion, according to equation 1, we actually found out that r squared equals to x squared times r squared over 144 plus y squared times x plus 12 squared over 144. In the next step, we join points A and C together by a straight line. By joining points A and C, we created the right triangle, triangle ABC. And then I copied the right triangle ABC in this new page and implemented the Pythagoras theorem on this right triangle, triangle ABC. This is the right triangle ABC that I copied from the original drawing. According to the Pythagoras theorem, in the right triangle ABC, AC squared equals to AB squared plus BC squared. Again, AC squared equals to AB squared plus BC squared. AC is r, therefore AC squared is r squared, and it is equal to AB squared. AB is y, therefore AB squared is y squared, plus BC squared. BC is also y, therefore BC squared is y squared. So in conclusion, we found out that according to equation 2, r squared equals to y squared plus y squared, that is 2y squared. So r squared equals to 2y squared according to equation 2. Now we can substitute r squared in this equation, equation 1, by 2y squared for this equation, equation 2. We did it and found out that according to equation 1, so r squared is 2y squared, and this equals to x squared times r squared. R squared is 2y squared over 144 plus y squared times x plus 12 squared over 144. Here we divided this equation 1 by y squared, and found out that 2y squared over y squared is 2, and here y squared will get cancelled, and we left only with x squared times 2 over 144. Here y squared will also get cancelled, and we left only with x plus 12 squared over 144. Here we multiply this equation 1 by 144, and finally found out actually that 2 times 144 is 288, and it is equals to 2x squared. In the denominator 144 will get cancelled, plus x squared plus 12 squared over 144 equals to x plus 12 squared. So here we open the brackets on this expression, and we found out actually that 288 equals to 2x squared, and x plus 12 squared equals to x squared plus 12 squared, that is 144, plus 2 times x times 12, that is 24x. So 288 equals to 2x squared plus x squared, that is 3x squared, plus 24x plus 144. Here we subtract 288 from this equation, equation 1, and we finally found out that 3x squared plus 24x and 144 minus 288 equals to minus 144, that is equal to 0. Here we divided this quadratic equation by 3, and we finally found out that 3x squared over 3 is x squared, and 24x over 3 is 8x, and minus 144 over 3 is minus 148. So we got the quadratic equation that x squared plus 8x minus 148 is equals to 0. So again, this is a quadratic equation, and the general formula for quadratic equation is ax squared plus bx plus c equals to 0. In this general formula, a, b, and c are the coefficients of this quadratic equation, and x is the variable that we are looking for. And we find out the value of x according to the following formula. X equals to minus b plus minus square root of b squared minus 4 times ac over 2a. In our specific quadratic equation, that is to say x squared plus 8x minus 48 equals to 0, the coefficient a equals to 1, the coefficient b equals to 8, and the coefficient c equals to minus 48. So here we just have to put the values of a, b, and c for our specific quadratic equation, this specific quadratic equation in this general formula for x, in order to find out the value of the values of x. We did it, and we got that x equals to minus b. b is 8, therefore minus b is minus 8, plus minus square root of b squared. b is 8, therefore b squared is 8 squared, that is 64, minus 4 times a. a is 1, so minus 4 times a is minus 4 times 1, that is minus 4 times c, that is minus 48. And minus 4 times minus 48 equals to plus 122 divided by 2a. a is 1, so 2 times a, that is 2 times 1, that is 2. So in conclusion, we have found out that x equals to minus 8 plus minus square root of 64 plus 192. And 64 plus 192 is 256. So inside the root, we left only with 256. And we have found out that x equals to minus 8 plus minus square root of 256 over 2. So x equals to minus 8 plus minus, and the square root of 256 is 16 over 2. So here we have two solutions that are possible for x because of the fact that x is the length of line 7DG, s is a length, and the length must be a positive number. Therefore, the negative solution is the irrelevant solution, this is the incorrect solution, so we will take into account only the positive solution for x, and the positive solution for x is x equals to minus 8 plus 16 over 2. Minus 8 plus 16 is 8, and 8 over 2 is 4. In conclusion, we found out of 3 that x, that is the length of this line 7DG, is equals to 4 units. Okay, thank you very much.